Greetings, everyone, and welcome to the first series of webinars focused on adoption and outputs within the Research Data Alliance. Today, we'll be focused on issues of data collection, data sharing, and data citation within the health space. You'll hear about two different outputs throughout our conversation, and you'll also hear from working group members and other RDA collaborators who have implemented these outputs within their own work and infrastructure. So the main objectives I would like all for you to learn, and I hope that you would leave today with, is to understand how RDA is supporting adoption of outputs and recommendations through a number of different activities, how RDA recommendations and outputs build both social and technical bridges to enable open sharing and reuse of data, as exemplified by the work across the health research that you'll be hearing about today as examples, and then how to engage with RDA to develop, adopt, and learn more about recommendations or output through a number of different pathways. So for brief introductions, my name is Anthony Juehne from the Research Data Alliance US office. You'll also hear from Leslie McIntosh, Dr. Leslie McIntosh, who is the Executive Director of the RDA US, as well as Oya Beyan from Aachen University. She'll be speaking about as a co-chair of the Reproducible Health Services Working Group. In addition, you'll hear from Mark Musen from Stanford University, who is representing the Center for Expanded Data Annotation and Retrieval, as well as the Center for Biomedical Informatics at Stanford University. I would also like to recognize John Graybiel, who could not attend this webinar today, though is also highly involved within leading the Center for Expanded Data Annotation and Retrieval group. I'd also like to recognize the Health Data Interest Group, as well as point you to the Reproducible Health Data Services Working Group. All of those links available there, you can learn more about those groups. In addition, I'd be remiss if I didn't recognize Marique Williams and Daniel Bengert, who are vital and really integral members within an adoption task force within the RDA Secretariat. Our focus currently is to enhance and support dissemination and adoption of RDA outputs through three main pillars: enhancing the findability and intelligibility of outputs, supporting adoption through education and training, and monitoring adoption and impact on a number of different metrics and through a number of pathways. So for the sake of my agenda today, the main flow for today I'll provide a bit of introduction and background on what RDA is for those of you who are newcomers and now just learning about the RDA. How we support adoption impact, the introduction of, provide a brief introduction of social and technical issues that some of our interest groups and working groups address, and how those are addressed through the outputs we'll be discussing today. Then we'll talk about the Health Data Interest Group and Reproducible Health Data Services Working Group, which Oya Beyan will address. Then we'll have a brief question and answer period there if any of you have questions about the output itself, so that we can handle those before we move into how those outputs are being used within two different adoption cases. One from the Stanford University Center for Expanded Data Annotation and Retrieval, which Mark Musen and I will discuss, and then the Washington University's Electronic Health Record Implementation of Dynamic Data Citation. Then I'll provide some more information about how to get involved in RDA and how to adopt some more of our outputs and learn more about our outputs and recommendations, and then wrap up with some more questions and answers. So for a bit of background, the Research Data Alliance is a global organization with over 8,000 members currently and growing. Focused on building the social and technical solutions to ensure researchers and innovators openly share data across technologies, disciplines, and countries to address the grand challenges of societies. Every twice a year, working group members and interest group members join in plenaries to actively engage in discussing emerging topics within data sharing challenges in the data sharing space, and then also work within their own working groups to develop their recommendations and outputs, though also this work is ongoing offline and in small task forces online. Once these recommendation and outputs are finalized, they go through a community review and approval process, and then the working group moves into a maintenance stage, wherein we aim to promote the adoption of those outputs to both a wider global community as well as the community within the RDA, and see how those outputs could be reapplied within other disciplines across different domains, and to address issues at multiple levels of stakeholders. If you'd like to learn more about these, some of our adoption stories and some of the activities that are ongoing to enhance the findability and intelligibility of our adoption stories and more about the outputs, please feel free to follow the links here to learn about those adoption stories, and we'll discuss more of those in a bit. So given the wide range of stakeholders and the wider range of community members coming to the RDA and participating in the RDA, and the diverse social and technical areas, there's a lot of work currently in bridging both how to address community and cultural practices, as well as some of the data and infrastructural practices. And working groups will often focus on one or two of those distinct spaces, but then a lot of the work comes in how to align efforts across working groups and interest groups, and also adopt multiple outputs and recommendations simultaneously. So my hope today is that you'll learn how each of these outputs could be adopted as individual outputs to address either a social or technical barrier, or they can be adopted in tandem, and the unique approach that comes from addressing both of those simultaneously. So to provide a bit of a landscape, what are the issues surrounding data collection and data sharing for reproducible health research? That'll be the focus today, but then the hope would be you can gain some interest in what other outputs and adoption activities are ongoing within RDA. So just some base assumptions that frame this work. The process of sharing biomedical data is not comprehensively documented. That's one of the issues. Effective and, one would assume, ethical health interventions require verifiable and reproducible evidence. And the responsibility of ensuring reproducible research involves multiple stakeholders across the research landscape and across the research workflow. For a base introduction of what reproducibility means and what we'll be discussing surrounding reproducibility, there's computational reproducibility, which is essentially if you share your code and your data, you're able to re-execute the same and produce the same results. Empirical reproducibility involves if you're able to document methods at a level of granularity to where one could re-execute those same methods, but using different data, and see where differences occur within those outputs. And then also replicability, where you actually actively create and recollect new data using the same methods of data collection, the same methods of analysis and preparation of the data, and prepare that for building your analyses and results. What is the real purpose of building reproducible scientific workflows is that reproducibility implies repetition, and thus a requirement to also move back to retrace one's steps, question or change assumptions, and move forward again. And the real main grand why and main purpose is the construction of a scientific heritage where anyone can validate the work of others and build upon it. So the main concern that these outputs are aiming to address: first, we'll discuss the issue that the reproducible health data services are aiming to address on the social side, which is how do we ensure all stages of data collection and preparation within the scientific compendium are fully transparent and appropriately accessible to achieve reproducibility. This involves multiple pieces of information and multiple decisions that are made within the data curation pipeline and the data brokerage services pipeline that will be discussed later. But then also we have more of a technical and infrastructural challenge of big data evolves rapidly in volume, variety, and velocity. How do we ensure traceable provenance of a data set from an evolving data source? This is really the infrastructural and data-centric challenge that the scalable dynamic data citation output is aiming to address, which you'll hear more about later. If you'd like to hear more about this output, you can follow the links below, which will link you to the working group, as well as an easy to use 2-page executive summary that discusses the output's impact. But my hope would also be that you'll learn more about it today. So now I will transfer it over to Oya Beyan, who will discuss the Health Data Interest Group and the Reproducible Health Data Services Working Group.
Yes. Hello, everyone. I try to share my screen, but
So Oya, I'll go ahead and shift through the slides if that works for
yeah.
you, and I'll mute myself.
Okay, can we start from the first slide? Okay. Today I will talk about our reproducible health data services working group, what we are aiming in this group, and what is the targeted outcomes. First, let's talk about a little bit talk about our problem. Mostly when we talk about the reproducibility of research data, we talk about the research data generated by researchers by following certain defined protocols. Those protocols can be clinical trials or experiments. But we also have another type of data which can be potentially used in this research domain, which is generated during the daily routine of the health care organizations and also by citizens themselves. In our scientific work, we know that this data is highly valuable. We can use this data for patient safety research, comparative effectiveness analysis, observational studies. And also this data is quite valuable from this data scientist point of view, since it can create high dimensionality data sets. But the problem is it is not really easy to collect these data sets. Next slide, please. Because these data sets resides in various environments in heterogeneous systems. Even inside in a hospital, you have different units, and you need to bring together this data from those separate systems with multiple types of data. For example, you can get one attribute from the annotations of images, or it can reside in a structured data source, or sometimes it's buried in this text data. So then each time you need to identify this resource, and we need to work with different types of this data. So it increases the complexity of reproducibility. Next slide, please. Another problem comes with heterogeneous standards. If we are lucky, those resources uses some standards, but in most of the cases, it's very difficult to map them. But when you are creating this data set, integrating different ones, you have to do this exercise anyway. Next slide, please. So, in health, reproducible health data services workflow, we identified the challenges of these health services. In order to make these services reproducible, what type of challenges should we target? First one is about the data creation process. Of course, this process requires to interact with multiple systems and needs huge manual effort and to map those different standards, transform them, and clean them. And when most of the tasks are done by custom-made scripts and queries, and typically they are not stored, or you can find any information about how they created. So at the end, this all extraction, transformation, and loading process is highly dependent on the creator itself. Can we go to next slide? In this process, we have very less documentation, if we have any. And also, there's a problem of creators do not know what to document. Besides being very time consuming, sometimes it is no clue about the granularity of this documentation. What could be the useful, what is vital, what can be left out. And there are no available standards and guidelines for this documentation procedure. When we come to the last stage, sharing this created metadata, created data sets does not come together with metadata. So typically they just hand over you this data set, but you don't know about anything on this data sets. Next slide, please. If we summarize this data creation process, actually it's more art than anything else. You can say that it's some little bit engineering effort because you are working with this data and integrating them. It's also a little bit science. You need to know your domain, and you need to be able to say what is your targeted patient profile. But at the end, all depends on capabilities of the individual doing this creation. Next slide, please. In our reproducible health data working group, we want to improve the reuse of health data by providing recommendations for reproducible data creation and brokerage services. In here, the questions that we are targeting actually, one is repeatability. So once I create a data set, can I create same data set in another organization or even within the same organization? Another problem might be assessment of the fitness. Once a researcher wants to use this data, can this researcher trust this data? If there is no metadata available, if the researcher doesn't know blood pressure measured by standing or studying, they will be very reluctant to use this data. Next, please. In our working group, we identified two deliverables. First one is a recommendation statement. We aim to perform a gap analysis. What is already there? What are the available standards? Our aim is not to come up with a new standard, but analyze the workflows of this creation process and try to map with existing standards, either produced by RDA or other standard organization. And if there's a gap or not enough maturity level for certain standards, then we can communicate this through the RDA with different working groups. Next, please. For that, we defined certain tasks. First, we identified the data creation process and created a workflow of activities carried on those different phases. And we start to document challenges related to each activities. Then we start to look available standard stack and map them. Next, please. Second deliverable will be an adoption and training guideline. Our aim is to document best practices, current state-of-art methods for this clinical data creation, and identify use cases and communicate these practices through the RDA. Next, please. I want to spend a few minutes about our current workflow. Mainly, it has data requests, data creation, and data sharing stages. We are thinking that data request is also within itself a valuable stage to identify certain challenges. Next, please. In this diagram, you can see a little bit better when we are talking about data requests, how this data request is formulated, what is the ethical evaluation, how this is assessed, are there any costs, and then like we are moving this creation process, and we are examining data extraction from the unstructured sources, unstructured and semi-structured sources, and data extraction from the structured ones. Then we have a bunch of transformation operations carried during the creation process, including data quality checks, mappings, transformation. At the end, when you want to share it, you need to properly provide the provenance information, metadata about it, and for the reuse licensing. Next, please. When we are having this data request elements, one of the important part, as I mentioned, is ethical assessment. For this data reuse, it will be very beneficial to have at least machine readable ethical applications. So there are some other RDA groups working on that direction. For example, our aim is to combine these different efforts and use these outcomes in our workflows. Next, please. When we talk about this data curation, like we are interested, what is the source of the data? Most of the time, like it might be transactional systems such as databases, but how we can cite these data sources, how we can create dynamic citations. And if we have a query scripts, are they fair? Are they commented? Can we share these scripts? And if we are using certain softwares for data cleaning and mining, can we make this information available so we will know how this data is extracted? Next one. When it comes to publication, so we need clear guidelines about how to publish these created data sets. What are the main components? Of course, FAIR principles gives us certain guidance, such as licensing, persistent identifiers, but at the end, what we should build at top of that and how we can extend this FAIR metrics based on the specific requirements of data creation. Next, please. This is the links for our draft document. So you will see this different phases, creation activities, explanation, and challenges. We will really like to get your comments, like did we cover everything? And are we in the right direction? Maybe there are some standards, some recommendations that we are not aware of, and we will really like to get your feedback on that. Next, please. In this link, you can find our case statement. We will be happy if you are interested to participate in our working group, give us feedback, or if you are interested in providing an adoption testing, we will be very happy. Thank you.
Thank you, Oya. So I don't see currently any questions coming in from audience, but if you do have any questions, do feel free to put them in the chat as we're moving along. I wanted to make sure if there are any questions about the output itself currently before we move on to how it's been implemented and how the adoption process usually goes, and some of the benefits and lessons learned there. If you have questions about the output itself, do feel free to drop those in chat, and we'll make sure to address those throughout or at the end. But now the aim would be to move on to, you've understood a bit of the process about how these working groups operate, how the outputs come to be developed, and some of the work that goes on there. And then once this is a finalized output, how is it actually used within the community? How does the adoption process go? What are some of the lessons learned there? So now you hear about two different adoption cases, and I'd like to welcome Dr. Mark Musen from Stanford, and I'll be online as well throughout this section to discuss a project in which we implemented that reproducible health working group framework into Stanford's Center for Expanded Data Annotation and Retrieval platform. Dr. Mark Musen, can you hear us?
Absolutely.
Perfect.
Thanks, Anthony. Let's just go directly to the next slide.
Perfect.
And I'll let folks know that we at Stanford have been working for the past 5 years or so on work to facilitate the authoring of metadata to basically make it more useful to investigators who want to be able to find other data sets, to reuse other data sets, and basically to take advantage of all the activities that make data fair. CEDAR is the Center for Expanded Data Annotation and Retrieval, and we were created under the National Institutes of Health Big Data to Knowledge Initiative. And we conceived our activities as a way of making it easier and more effective for bench scientists to put their scientific data online into repositories. And it's just been very exciting for us to be working with the Health Data Interest Group to be able to explore how CEDAR might have value for providing rich metadata to make it easier to access and integrate data related to clinical medicine. So when one goes to the CEDAR platform, what one gets is an environment that makes it easy to create templates that will allow one to describe the kinds of metadata that are relevant for different classes of scientific experiments or essentially digital research objects, because one of the things that we've learned through CEDAR is that we can use the same approaches not only for the kinds of metadata annotations that are important for data sets, but for all kinds of things that people want to be able to put online and to index. What we see here is the workspace that Anthony created. I'm assuming that Anthony did most of that work in facilitating the use of CEDAR to access the clinical data that you'll hear about in a bit. CEDAR gives you the ability to create templates, to then use those templates to instantiate information regarding particular digital research objects, and to upload those metadata descriptions to the repositories where those objects get stored. Why don't we go to the next slide? What makes CEDAR particularly effective is that we allow data to be annotated with all kinds of information. So alphanumeric information is just plain text, numerical descriptions, Boolean descriptions, which gives us the ability to have names, titles of experiments, journal publication information, and so on. We can have data terms or metadata terms that relate to software files or associated data files, and everything in CEDAR has a unique identifier, which we hope is persistent, so that the information that is entered as metadata is preserved and obviously searchable over the long haul. One of the things that CEDAR also does is to make it simple to associate with the entries in these metadata templates terms that are structured and standardized, terms that come from clinical ontologies, terms that come from the common data elements that have been developed by the NIH for a variety of purposes. And that means that when one uses CEDAR to create metadata to describe some research object, it's possible to ensure that the diagnoses, the procedures, the medications, the labs, all the things that people care about and want to search for are described using the standardized terms that will assure that when one does a search, that information comes back with good recall, and also to assist in the integration of data sets so that we are calling diagnoses and procedures and whatever by the same terms throughout the data sets that are stored in some repository to assist with integration. Next slide. So here's an example of what one of these templates looks like. This is actually a template that was created as part of the experiment that we're talking about here. Anthony, you may want to lead people through the template.
Yes, so to offer a bit of framing of our thinking in how to adopt the working group workflow into the CEDAR platform, the aim was that the working group framework was essentially, you saw that diagram earlier of all these terminologies and a breakdown of phases of the data curation and data brokerage process, including the data cleaning process and how this data is prepared for analyses, and finally how it's prepared for sharing. But those phases are are being analyzed and being assessed by a number of members within the working group and a number of members within the RDA community, which is great to have that level of representation. But the aim would be as opposed to creating just a workflow diagram or another list of checklists. How do we actually integrate those variables within a standardized template that would make it easier to use and adopt those recommendations and those recommendations? So we would use the SEER templates, build metadata elements within those templates that could then be crosswalked to existing metadata standards and additional ontology standards, and easier preparation of that data for linking to additional research outputs or easier export, which you'll learn about a bit more. So the aim was, how do we take something that is relatively theoretical and a list of terms and checklists, integrate it into a technological platform to support that social practice and that cultural practice, and move the needle a bit more in how people are documenting that data and integrating that practice within their own workflows. So it's a very easy to use platform in the sense of those templates, but you'll learn a bit more about some of the capabilities of exporting the data and linking to additional pieces. So again, this is to walk you through a bit more of those phases. Here's basic project metadata, which is something like a project title, the institution of the principal investigator, where is this health research being conducted. We discussed a bit about the ethical assessment, so you could link to the actual IRB protocol ID and a link to the IRB protocol document, so that when someone reviews an actual publication and some of the data that's exported and associated with that research, they can see the limitations and processes in which that IRB was approved and access all of those materials within the same output or within the same metadata repository. In addition, here's a further breakdown of how you can nest multiple fields in a sense like a family tree, and show a more granular relationship between all of these sub processes and sub elements within those wider phases. So say something like data access, you would require a database DOI, the actual database URL. Where was this, in a sense, where was this data hosted before it was queried in a secondary nature? And then say the structured processes of extracting data and extracting structured data. You have all of those issues surrounding how is data actually queried? What are some of the limitations in cohort construction? So might there be, how were the actual clinical cohorts operationalized against the clinical ontologies within that data set or within that data warehouse? And all the actual pieces of materials like an SQL script or a list of those cohort inclusion ontologies or diagnoses codes or operation codes within the same structured file. So if you think kind of a twofold process, if I'm a data broker collecting data, I can easily document these processes within the same template and within the same platform to aid in implementing those recommendations within my own workflow and practices. But then also, if I'm a researcher attempting to assess and reuse data, I can then see this metadata template and this metadata file that's associated with that final data set to see the full entire research workflow. Now, the thought would be, how would this actually be implemented and scalable across a number of different example cases? So within Stanford, I worked with Rohit, Dr. Rohit, and a number of members within the biomedical informatics community to look at some of their projects. And we're aiming to continue some of this testing to evaluate the functionality and generalizability and scalability of this process. But I'll walk you through a sense what this might look like for an individual project. So here is a type 2 diabetes project, which was conducted within the Odyssey platform. So these are Odyssey are epidemiological studies that are conducted at individual sites, one being conducted at Stanford, but say another one being conducted at Princeton, where they aim to collect cohorts in the same standardized manner and against the same standardized data model, and assess the same results, but the aim would be to gain a larger cohort, given that you can rerun those same queries and collect data in the same way across multiple sites. So here they have a standard way of documenting their protocols within simple PDFs, and they often use things like GitHub. But the idea would be, how do we build something like this where we can have all of those associated elements within a simple and easy to use metadata repository, where we can easily link to all of those pieces and all of those additional pieces of material and all of the sort of dependencies within those processes, so that would be easier to assess some of the limitations, some of the actual workflow processes, and get a granular view of how to reproduce some of those protocols. One of the main values that something like CEDAR has, and something like this this adoption project offered, would be the ability to map some of these clinical ontologies and clinical questions to existing ontologies and vocabularies and standards within the templates. Mark, I don't know if you'd like to speak any more to this point, but we viewed it as a great benefit to be able to take some of those phases, which were again, those phase diagrams, which were quite theoretical, and see how you could actually operationalize them and collect and prepare that data for sharing, in a sense, in like BioPortal or other associated repositories, by crosswalking to those existing ontologies to increase the granularity and robustness of that metadata documentation.
Well, I'll just add that BioPortal is the world's largest collection of biomedical ontologies and controlled terminologies. And CEDAR has been developed to work directly with BioPortal to make it easy to specify which ontologies could provide terms to allow scientists to create metadata with very explicit controlled terminology. But at the same time, BioPortal is adoptable for a number of different domains. There's nothing specifically biomedical about it. And so BioPortal has been used in the agronomy community, in the geosciences community, and some others, to show that scientific ontologies can be easily accessed in a standardized mechanism. And CEDAR is just a really good example of how those ontologies can be reused for the purposes of making sure that the metadata that are created for various data sets are consistent, and allowing the underlying data to be fair.
Thank you. So in thinking through how this data could be both inputted into some of these templates to allow for the adoption of those best practices, but also how could this be more easily machine readable and exportable for preparation of sharing this data within other associated repositories or across sites and labs. One main benefit is that you can export this data both in a tabular format, but then also you can export it as JSON and RDF schemas, and that allows this to be much more machine readable than something than just a simple checklist or diagram workflow. So again, just a reminder of the thinking here is, how do we take something of a working group output, really implement it in a way to increase the usability, machine readability, and impact and scalability of it. Some of those potential use cases, we're exploring how to continue using this with Odyssey and test it a bit more. We've also been in contact with Research Data Canada and a number of different sites, but we view this as something that could be applicable both across the health field, but then this thinking of any use of secondary data would often face these same issues of how to make sure those processes of data curation are included within that final research output. So how we could potentially assess impact and scalability with more use cases, conduct some more iterative reviews within the RDA community to vet more granularity and assess more interoperability. And then, of course, continued collaboration with CEDAR to test and develop the functionality and really see other research outputs that we could potentially link to this metadata, and how to use this metadata in a more robust fashion to improve the reproducibility of workflows. Before we move on, I want to make sure, before we move on to the next adoption test case, Mark, if there's anything else you'd like to add.
No, I think we're in good shape.
Yes, thank you so much. Yes. So now I will like to turn over to Leslie McIntosh, who will be speaking about the Washington University Center for Biomedical Informatics adoption test case. And all right, Leslie, can you hear us?
Yep. Can you hear me?
Yes.
All right. Thanks everyone for joining us today. I am going to give the second use case, which is going to be a bit more taking another output from RDA and incorporating it into an evolving data repository. So this this was when I was over the Center for Biomedical Informatics at Washington University School of Medicine. So just as an FYI, I'm actually now with the Research Data Alliance, but I can still talk to this in the team. So the first thing that you should notice is that there were quite a number of people involved, which included Sneha and Connie, who are informaticians, and Brian, excuse me, Daniel, who was a database administrator, Cynthia, who's a data librarian, and then myself to work on this. So go ahead and go to the next slide. Another thing I'd like to mention is that this was made possible by a MacArthur Foundation adoption grant, which was $40,000. So that's not a huge amount, but because we had the infrastructure of the Washington University CTSA, which is an US NIH funded program, and the Siteman Cancer Center at Washington University, we had the infrastructure to support taking the RDA adoption and implementing it rather rapidly. Go ahead and go to the next slide. These are just resources, so when you have the slides, you can go back to them. So go ahead and, yep, I'm going to talk through the background. Go ahead to the next one. So what we had was really what I called biomedical data as a service. We had a biomedical data repository, which I'll talk about in more detail, data brokers who could access identified data. We also had an application, an I2B2 application that could be self-service. And what the idea was to get it to researchers who had approval from our institutional review board, and then also questions that they needed answered based on these data. And so go ahead to the next slide. The idea really was, how do we facilitate moving some of the responsibility of reproducibility from those biomedical researchers, incorporating the principles of reproducibility into that biomedical pipeline? And we thought that using the recommendations from the Evolving Data Citation Working Group would be a great way to test out. So go ahead to the next slide. So what we did was we looked at the recommendations coming out of, for short form, the Data Citation Working Group, and there were 14, and I apologize that I'm in the airport, is that there were 14, and our team really looked over which ones could we look at. So these included data versioning, which is making sure that we can retrieve earlier states of data sets that need to be versioned, data time stamping, which you would think would be obvious, but as you'll note when I go a little bit further, that was not obvious. We had not implemented that into our system, into our database. And then it's really important to really capture information about the query, provide a means for storing the query, the associated metadata, time stamping the query, so not just the data, having a persistent identifier for the query, and then also having a query citation, which provides a recommended citation text and the persistent identifier to the user. So go ahead and go to the next one. So our project was to implement the citation recommendation into our Washington University I2B2, engage with other communities, which in the United States there are quite a number. I know that it's also beyond the United States, and then contribute back the code back to the community. Go ahead and go to the next slide. So what we did was, our approach was first to assess the center's data infrastructure, conduct the gap analysis, define our local requirements, and then define and evaluate our approach. So go ahead to the next slide 10, and I'll take you through. This was our infrastructure. We had a clinical data store that really came from the hospital, and that moved all of the electronic medical record data into an identified data repository that was very much in a secure environment that few people had access to, but the data brokers were people who had access to that. There were also other stores of the data depending on who needed it. And so if you'll notice, our original goal was actually to transform the I2B2 application, but what we really made the changes were in the identified data repository. So go ahead and go to the next slide. So when we conducted a gap analysis, we looked at our local I2B2 and we actually didn't have some of the information like the query store or a query timestamp or a query persistent identifier or citation text. So it was very helpful for us to have these in front of us to look at what was important and to see about going and changing those. So we did this gap analysis. And then if you'll go on to the next one, the next thing we wanted to do was look at what were our requirements. So they gave us what we should do, but what did we need? We needed to be able to handle large volumes of data efficiently and relatively fast because versioning requires storing history of changes to data, as well as scanning and updating large amounts of data. It had to be implementable for Postgres because that was the database that we used. Our software tools must have regular updates and maintenance support from the community. So otherwise, the software tools used should be understood by in-house developers. It should be relatively easy to implement to allow for easy maintenance and upkeep, and it should be relatively easy to use for data brokers as they would need to run queries and access query audits. So that was our internal requirements. So go ahead and move to the next. Here's what it looked like in implementation. In our proof of concept for our database for timestamping and versioning, we used the temporal table extension for Postgres. So each live data table that needs logging was given an additional column named sysperiod, which holds a timestamp range value, identifying the start timestamp, the end timestamp, and boundary condition of when the record is or was valid. A second copy of each live data table was created to hold historical data. Now, these historical tables have the same structure as the live data tables, but without the same primary keys and are used for logging each data change. The trigger provide a temporal table extension was added to each live data table before the insert, update, and delete transaction. And this trigger inserts a copy of the existing row from the live data table into the historical table with the timestamp range modified to show the current date. Okay, go ahead to the next one. During the incremental ETLs, which is exchange, transform, load from clinical data sources, our ETL identifies whether a row of data is updated or inserted to existing in the data repository, the RDC. And if it's an update, the data in the RDC.table gets updated to the new values. However, we did set up triggers before each update or delete, if any, so that there would first copy the original field values from the history table and then only then allow the update. And I have some more technical details that I'm going to skip. Yep. So in order to implement the RDA recommendations, the 3, 7, 8, 9, and 10, really regarding the query metadata, we had to have a way to store the query metadata, the query timestamping, the persistent query persistent identifier, and the suggested query citation. So as you can see, in addition to using the temporal tables extension, we also created a view as a union between each live data table. And several functions and triggers were set up to allow for storing user data and query data into the query audit table. And we do have a paper on this that you can read if you want more details, so I won't go into any more details, but let me get the take-home message. So if you look at the data reproducibility workflow, what happens in a time point of today, the data broker runs a query on the special view, a view over a union of live data and the historical table. The query run is audited automatically, storing the query, its metadata, the date of execution, the persistent identifier, and the suggested citation. The data broker gets back the data and suggested citation containing a query date and a query persistent identifier, PID. Sometime later, though, the data broker can reproduce the results received for the query PID by providing that PID to a special function to rerun the query. Now, this was huge because when we tried to rerun queries before, it actually was recreating the query. And you would think that just by having the same code, you could rerun it, but that was not always the case and get the same data. So that was a phenomenal addition. And then there was also one other thing that was just added on the next slide. And the added feature was just a way for the data broker to find out whether the version at the time of the query with a certain PID actually changed over time, just comparing it to the current data version. If the data hadn't changed, the results and functions would be false. Yep. And the take-home message, what this did is we ran services, and it usually took about 20 hours on average to complete one study. So a researcher would ask a question, we would clarify the question, develop the query, and it would take about 20 hours to complete. If we didn't have a subsidization, which was from the NIH, it was about $150 an hour to have this. So about $3,000 per study to happen. So that $40,000 grant from the MacArthur Foundation actually had a return on investment once 14 studies were needed to be replicated. And just to give you an idea, a researcher might come back 6 months later and want to build off of the previous research or reconfirm something. So that actually happened rather frequently. There's a lot of people that worked on it, so I just wanted to make sure that I gave them credit. You can see those in the slides, and then there's also a repository that's still up, and the slides and the bibliography that you can look for as well.
Thank you so much, Leslie. So you've heard a bit about how these outputs come to be developed. You've heard some example use cases of how they can be implemented and some impacts and additional uses in which they could be scaled to other stakeholders or other domains within the scientific community, and understand in a general flavor the sorts of technical and social issues we aim to address as an organization, as well as within our own working groups and as an adoption task force team, what we aim to address in promoting these outputs and recommendations. So I just wanted to wrap up very quickly and ask you to, if you're interested in joining our community or learning more, you can access here in the slides, and these will be shared, a link to all of our recommendations and outputs. You can view all of our adoption stories, and then if you yourself have used an RDA output or an RDA recommendation within your own work, we would love to hear from you, so you can follow a web form there to submit your own adoption story. And we really look forward to hearing more about your own adoption stories and your own input here. Within the upcoming plenary in Philadelphia in the beginning of April, we'll be holding a number of events focused on adoption, in which we'll be launching an adoption poll to hear more about how people have learned about adoption and our recommendations and outputs, and hear more about how this has influenced their work and what we could do as an organization to help support that more, as well as provide some more insight into our current strategies and our current strategies to both support adoption, monitor adoption, evaluate impact, and support further growth of these outputs and recommendations within our organization. So I want to open it up now if there's any questions in the chat, or if anybody has questions either regarding the organization, our particular work within the health field, or questions regarding how we are promoting and supporting outputs and recommendations within the broader community. Okay, I see some questions. I see a question of new ontologies for health are expanding, growing. Is there a process or consideration for including new ontologies? So this is a great question, which I think is a large benefit of some of the work that exists within our own working group and within the RDA community as a whole, is that the general wide scope of the people that participate within the organization it allows us to be aware of how those new ontologies are being developed, and it really allows us to integrate some of those new ontologies within our own work, because be it people that are in the metadata community, be it people that are in the ontology and development community, or people that are in the library space, as working groups, given the wide scope of representation of all of those team members and all of those people within the community, it really helps in incubating how to make sure that we're addressing those particular issues, including like how ontologies are changing or how repository management is changing. It really allows us to be more aware of how that landscape is changing, as opposed to operating in more of a siloed, purely clinical, purely health, purely focused on one-off projects. That sort of incubation that exists within the RDA community, we view to be very helpful in knowing how those ontologies are changing and how those changes are advancing within the data science community as a whole.
And this is Mark. I'll just add as a practical point of reference, the ontologies and terminologies that are in BioPortal are updated on a regular basis. We, for example, scan the ontologies that are in the OBO community, and we update those nightly. Whenever there's a new UMLS release, those ontologies get updated automatically as well. And as Anthony said, RDA provides a great vantage point to sort of survey what's happening in the world of scientific ontologies and make sure that we can track those and make sure that changes are made and updates are made at an appropriate time.
So, Mark, this also might be a question for you regarding CEDAR's functionality. Is CEDAR and the tool attached to a particular repository, or how is the created metadata integrated with a repository system where the data is deposited? Or is it for an index that is separate from the data repository? So if I understand correctly, how is the data actually held within CEDAR in addition to the creation of those templates?
Right. Well, people use CEDAR to use the templates to create the metadata that are structured and annotated with the ontology terms and other structured elements in a way to ensure that the metadata are as complete and comprehensive as possible. And then CEDAR allows those metadata and the corresponding data sets, which presumably are sitting on the user's desktop, to be uploaded to the appropriate repository. The sad news is there are no standards for repositories. That's actually another area where RDA can be very effective. And so currently, for every repository that one might want to use, we have to actually create custom code in order for those repositories to be linked to CEDAR. But there are a large number of scientific communities that are using CEDAR where we have created the appropriate linkages, and the metadata and the corresponding data sets get uploaded automatically.
And from our vantage point as a thinking about how this might be used from a clinical point of view, or as a working group of how these best practices or recommendations could be actually integrated, the thought would be, as opposed to that metadata or those documentation practices regarding the data curation pipeline and the data brokerage pipeline simply being documented within, say, an internal lab server or an internal lab wiki, it could be held in something like CEDAR as well, and then, as Mark mentioned, prepared and exported and shared with a data repository or say a publisher, etc. So it's really trying to make sure that data doesn't just stay rested and stagnant in an internal lab silo. As ethically and security provides, how can it be shared within CEDAR and then associated with other repositories? So this is a question of, hello, I'm developing a web platform to manage clinical trials. I want to apply standards based on RDA recommendations. Thank you. Please reach out to us if you'd like to learn more about how it could be applied to your own clinical trial work. I think this certainly aligns. Patricio, if you'd like to learn more, we'd be happy to follow up with you offline, as I certainly think this could be a use case within managing multi-site clinical trials or single-site clinical trials, much like the Odyssey multi-site epidemiological studies. It's very much in line there, and that's exactly the sort of adoption cases where I think that could be useful. This presentation will be shared, the slides will be shared, and this has been recorded, so you can both access the slides and this full recording later. If that's all the question for the time being, I don't want to hold anything up. I do see, I'm curious what fraction of software used are free so the data metadata can be used, reproduced. Are there environmental setting and installation also documented in the metadata? So one of the main pillars of RDA is that it's all, the aim would be to be completely in line with open source, open licensing, and ensure everything is freely available and open source. If that addresses all questions and concerns and thoughts for the time being, do not hesitate to reach out to us. Again, you'll have links and be able to access anybody from our team within the adoption team. And we look forward to hearing your thoughts about how this webinar might be applicable and help you. And look forward to your feedback and further questions. And for those that are attending in Philadelphia at the plenary, I look forward to seeing you all there. Thank you so much to everybody that joined us on this webinar. Particularly thank you so much to Oya, Leslie, and Mark, and Marique, Daniel, and Andreas for all of your help in this. And I look forward to hearing from you all. Thank you.